Hi students, good afternoon. Am I audible to you? Okay. So today we can start a new topic, that is binary codes. What is a binary codes? And what are the different codes we are used for representing numbers? Okay. As we know that in digital data, for storing digital data and for transmitting digital data, we will use these binary numbers only. We will use a group of binary numbers for storing and transmitting their digital data. That you already know that. So this group we will call it as a binary code. Okay, the binary code is represented by numbers as well as alphanumeric letters. In that, first we can discuss about decimal codes. Okay, that means binary codes for decimal digit 0 to 9. Okay, how we will represent these decimal digits by using these binary codes. Okay. So for representing 0 to 9, actually it is a 10 symbols are there. Okay. We have 10 different combinations. 0, 1, 2, 3, up to 9. Okay. So it requires minimum 4 bit to represent the 0 to 9. That we know that. Okay. So here there are different decimal codes are there. We can discuss each. First one is 8421 code. This is a BCD code that we already studied. 8421 code, BCD code. What was that 8421 BCD code? 8421 BCD code. What is that? How we will represent a number in BCD form? Arunima, how we will represent a number in BCD form? Arunima P. This is already we studied, isn't it? Arunima. Present alle Arunima. Nabil. Nabil K. How we will represent numbers in BCD form? Ahila. How we will represent? Ahila. Ahila പറഞ്ഞേ. BCD. Last class we had studied. Ahila is
4 bits ആയിട്ട് represent you.
okay. Each digit we will represent as a 4-bit binary number. Correct. Each digits in the decimal we will represent it as a 4-bit binary number. Correct. Okay. So that we already studied. BCD code. Okay. Wait. 8421. Next, another decimal code is 2421 code is there. Then 84 minus 2 minus 1 code is there. Then 5043210 code, that we will call it as a biquinary code. Okay. And XS3 codes. So these are the different decimal codes that we had to study. Okay. One that is 8421 code, we already studied that. So now we can study what is a 2421 code, 84 minus 2 minus 1 code, and 5043210 code. That is binary code and XS3 code. First we can study 8421 code. 8421 code. Actually, here the weights of these codes are 2421 code. Okay. So here the weights of these codes are 2, 4, 2, and 1. Okay. And this code have all positive weights. All values, all these weights are positive only. That means 2, it is a positive number. 4, 2, and 1. All these weights are positive values also. Okay, and also it is an unnatural BCD code. Unnatural BCD code. Unnatural BCD code means the sum of the weights of an unnatural BCD codes are equal to 9. Okay, so that is what unnatural BCD code. Unnatural BCD code means whose sum of weights is equal to 9. Here you can see 2. These are the weights, and that is 2, 4, 2, 4, and 1. Okay, sorry, 2, 4, 2, 4. Sorry, 2, 4, 2, 1. Okay, so these are the weights. Okay, 2, 4, 2, 1. So these are the weights. Here, the sum of the weights are equal to 9. That means 2 plus 4, it is 6, plus 2, 8, plus 1, 9. Okay, so the sum of the weight is equal to 9. That means it is an unnatural BCD code. Okay, here these are the examples of these 2421 code. So for representing 0, we will use 4 digit to represent each numbers. Okay, in a BCD form, we will use 4 digits. Okay, here in 2421 code, so for representing 0, this is the code 000. Okay, 0000. Then for 1, it is 0001. Then 2, it is 0010. Then 3, 0011. 4, 0100. 5. So for representing 5, how we will represent it? It is 1011. That means 1011 means what? Actually, our code is 2, 4, 2, 1. Okay, 2, 4, 2, 1. Here, in the place of 2, it is in case of 5. If you are representing a decimal digit 5 into 0, 2, 4, 2, 1 means what? Here in place of 1, we have represented it as a 1. Then this is also 1. This is 0. And this will be 1. That means 2 plus 2 plus 1. It is 5. Okay, likewise we will represent the 2, 4, 2, 1. Similarly for 6. Okay, similarly for 6, it is 1, 1, 0, 0. Okay, 1, 1, 0, 0. That means the positional weight value is 4. Here it is 4 and here it is 2. That means 4 plus 2, it is 6. Okay. Similarly for 7, it is 1, 1, 0, 1. That means 2 plus 2. Here it is 2. It is 4. That is 2 plus 4. It is 6. Then this is 0. Plus 0 plus 1. That means it is 7. Okay. So these are the examples of an 2421 code. Okay, 2421. You need to remember this point that in 2421 code, the weights of these codes are 2, 4, 2, and 1, and all the weights are positive. That is why we will call it as a positively weighted code. Okay, it is a positively weighted code, and it is an unnatural BCD code. Unnatural BCD code means whose sum of the weights is equal to 9. Okay, then one more thing you need to study in case of 2421 code is it is a self-complementing code. Okay, it is a self-complementing code. What is a self-complementing code? Self-complementing code means self-complement code provide the 9th complement of a decimal number just by interchanging ones and 0 in its equivalent 2421 representation. We can see what is a self-complement code. Suppose consider the value 5. Okay, 5. Here in 5, what is the equivalent 2421 code? It is 1, 0, 1, 1. Okay, for 5, it is 1011. So this is the equivalent 2421 code. Okay. Then, if you find the ninth complement of 5, what is the ninth complement of 5? Anybody? What is the ninth complement? How we will find the ninth complement of a value? And tell me the ninth complement of 5. Anybody? How we will find the ninth complement of a value? Anybody? Gopika, how we will find the ninth complement of a number? Gopika, how we will find the ninth complement of a number? Gada, how we will find the ninth complement of a number?
Subtract
each
bit from
digit
9.
from
Okay. We have to subtract it from 9. Correct. We need to subtract it from 9. So, what is the ninth complement of 5? It is, we need to subtract, that is 9 minus 5. It is equal to 4. Okay, it is equal to 4. So, this one. Okay, 4. 4. Okay. Then if you see the 2421 value of 4, it is 0100. That is the 2421 value. Okay. That is 0100. Okay, 0100. From this, you can see that if you interchange the values of 0 with 1 and 1 with 0, then you will get this value. See, so in 5, this is the 2421 code, that is 1011. Okay. Then, if you find the ninth complement of 5, that is 4, that is 0100. That means you just interchange the value, that is 1 with 0 and 0 with 1 in a decimal digit, then you will get the corresponding ninth complement. അല്ലേ? അതായത് നിങ്ങൾക്കിപ്പോൾ ഇവിടെ 5 എന്ന് പറയുന്ന ഒരു 2421 കോഡ് ഇവിടെ എഴുതി. ഓക്കെ, അതിനെ ജസ്റ്റ് നിങ്ങൾ ഇന്റർചേഞ്ച് ചെയ്ത് 0 with 1 and 1 with 0 ആയിട്ട് ഇന്റർചേഞ്ച് ചെയ്ത് എന്ത് കിട്ടും നിങ്ങൾക്ക്? യു വിൽ ഗെറ്റ് ദ കറസ്പോണ്ടിങ് ninth complement. That is 4 കിട്ടില്ലേ? That means if you interchange the value 1 with 0, so it is 0, then here it is 0, then 0 with 1, then 1 with 0. This is the equivalent ninth complement value of 5. Okay, so this is what self-complementing code. Self-complementing code. That means self-complementing code provides the ninth complement of a decimal number. Okay, that means in 2421 code, if you take a decimal number 5, then if you just interchange the value of 1 with 0 and 0 with 1, then you will get the corresponding ninth complement of that value. Okay, so that is what a self-complement. Okay, so here in 2421 code, it is a self-complementing code. Okay, so these are the points you need to remember. Actually, 2421, whose weights are 2, 4, 2, and 1. That is, all weights are positive weights. So we will call it is a positively weighted code. And it is an unnatural BCD code. Unnatural BCD code means sum of weights of unnatural BCD codes are equal to 9. Okay, whose weights sum of weights is equal to 9, then it is an unnatural BCD code. And also it is a self-complementing code. Self-complementing code means if you find the ninth complement of a decimal digit, then it is what? If you just interchange, if you just perform a complement operation of that, then you will get the nines complement of that number, decimal number. So that is self-complementing code. Self-complement code provide the nines complement of a decimal number just by interchanging ones and zero in its equivalent to for 2 1 representation. Okay, so that is 2421 code. Okay, then one more, another code is 84 minus 2 minus 1 code. 84 minus 2 minus 1 code. Here in this 84 minus 2 minus 1 code, the weights are what? 8, 4, minus 2 and minus 1. Okay, so these are the positional weight. 8, 4, minus 2 and minus 1. Okay, and this code has a negative weights here, minus 2 and minus 1. You can see these are two negative numbers. Okay, so this code has a negative weights along with the positive weights. Okay, so it is called a negatively weighted code. Okay, it is called a negatively weighted code. That means it is having negative code along with the positive code. Okay, and also it is an unnatural BCD code. That means if you add the weights, then the result will be 9. That means 8 plus 4, it is 12. Okay, 12 minus 2, it is 10. 10 minus 1, it is 9. That means sum of positional weight is equal to 9. Then we can call it as an unnatural BCD code. Why it is unnatural BCD code? Because sum weighted sum of weights is equal to 9. Okay, and also it is also a self-complementing code. Self-complementing code means we already studied that. What is self-complementing code? Self-complementing code provide the nines complement of a decimal number just by interchanging ones and zeros in its equivalent. Here it is, if you just interchange the ones and zeros in its equivalent 8421 code, then you will get the nines complement of that number. Okay, so that is 8421 code. 8421. So these are the 8421 code. 0 for representing 0, everything is 0. Then for representing 1, the corresponding 8421 code is this one. That is 0 1 1 1. That means positional weight. So for representing 1, so positional weight of this, here actually it is a 8421 code. Okay, 8 4 minus 2 minus 1. Okay, so these are the positional weight. 8 4 minus 2 and minus 1. Okay, then so this is the positional weight. Here it is 4 plus minus 2. That means 2 minus 1. That means 1. So this is equal to the decimal value 1. Okay. അതായത് ഇതിന്റെ വെയിറ്റ്സ് ഒക്കെ നമ്മൾ 1 എന്നുള്ള പൊസിഷനിലുള്ള വെയിറ്റ്സ് ഒക്കെ ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ അതിന് ഈക്വലന്റ് ആയിട്ടുള്ള ഡെസിമൽ വാല്യൂ കിട്ടും അല്ലേ? സോ 3 എങ്ങനെയാണ് നമ്മൾ റെപ്രസെന്റ് ചെയ്യപ്പോൾ? 3 എന്ന് പറയുമ്പോൾ ഇതായിരിക്കും 0 1 0 1. That means this is 8, position 8, this is 4, this is minus 2, this is minus 1. Okay, here 4 minus 1, that means 3. Okay, so this is the equal and the decimal number corresponding to the 84 minus 2 minus 1 code. Okay, 84 minus 2 minus 1. And also it is also a self-complementing code. Self-complementing code means, suppose if you take a number, say 6. Okay, 6. So corresponding 84 minus 2 minus code is 1010. 1010. Then find the complement value. It is 0 1 0 1. Then if you find the 9's complement of 6, it is 9's complement of 6 means 9 minus 6. It is equal to 3. Okay, so corresponding value is 0, 1, 0, 1. That means if you find the 9's complement of a decimal digit, just എങ്ങനെയാണ് നമുക്ക് കിട്ടിയിരിക്കുന്നത്? ഈ വാല്യൂസ് ജസ്റ്റ് ഇന്റർചേഞ്ച് ചെയ്താൽ എന്താണോ നമുക്ക് കിട്ടുന്നത് അതെന്ന് പറയുന്നത് എന്തായിരിക്കും? അതിന്റെ ഒരു 9's കോംപ്ലിമെന്റ് വാല്യൂ ആയിരിക്കും അല്ലേ? സോ ദാറ്റ് ഈസ് സെൽഫ് കോംപ്ലിമെന്റിങ്. Okay, so that is all about 8421 code. Okay, 8421 code. Actually 8421 code എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താണ്? Whose positional weights are 8, 4, -2 and -1. And we will call it as a negatively weighted code. Why we will call it as a negatively weighted code? Because it is having negative weights along with the positive weights. So it is negatively weighted code. And also it is an unnatural VCD code. Means sum of weights is equal to 9. Like 8 plus 4 minus 2 minus 1. It is equal to 9. So it is an unnatural VCD code. And also it is a self-complementing code. That means if you interchange the positional value 0 by 1, then you will get the corresponding 9's complement of that number. So that is why it is a self-complement code. Okay. Then next code is 5043210 code, or we will call it as a biquinary code. Okay, biquinary code. So that is 5 0 then 4 3 2 1 0. Okay, so it is biquinary code. Here positional weights are this, that is 5 0 4 3 2 1 0. So in biquinary code it can be grouped into 2. Okay, that is first group is 5 and 0. Okay, then next group is 4 3 2 1 0. Okay, so the first group 5 and 0, and next group is 4 3 2 1 0. Here the first group, that is 5 and 0. Okay, it represent, that means this first group represent, suppose if the bit value 5 it is equal to 1 means the number is greater than 5. Okay, if the bit value corresponding to 5 is 1, then we have to understand that the number is greater than 5. Okay, and if the bit value that is corresponding to 0 is equal to 1, means the number is less than 5. Okay, so this is the point you need to remember. Okay, so actually in biquinary code we will group into 2 groups. We will separate that into 2 groups. First group is 5 and 0, and next group is 4 3 2 1 0. Okay, here in the first group the bit value corresponding to 5 is equal to 1 means we have to understand that the number is greater than 5. Okay, and if the bit value corresponding to 0 is equal to 1 means the number is less than 5. Okay, so that is what I have written here. A 7-bit weighted code. The two bits of which are used to indicate whether encoded number is or not at least 5 in value. The remaining 5 bits comprising 4 zeros and a single one whose positional is used to determine the number completely. That means remaining 5 bits നമ്മുടെ number represent ചെയ്യുന്നു. Second group 43210 specify the actual number. Okay, second group specify the actual number. So first group എന്താണ് ചെയ്യുന്നത്? First ഗ്രൂപ്പിൽ 5ന്റെ പൊസിഷനിൽ 1 വന്നു കഴിഞ്ഞാൽ we can understand that the given number is greater than 5 ആണ്. Okay, then 0ന്റെ പൊസിഷനിലാണ് വന്നിട്ടുണ്ടെങ്കിൽ എന്താണ്? We can understand that the given number is less than 5. And the second group specify the actual number. Okay, and each decimal digits by using this 5043210 consist of 5 zeros and 2 ones. ഓക്കെ, സോ ഇതിൽ ആകെ നമുക്കുണ്ടാകുന്ന 5 സീറോസും 2 വൺസും ആയിരിക്കും. അപ്പൊ അതിന്റെ പൊസിഷനിൽ മാറിയിട്ടുള്ള അതിന്റെ പൊസിഷൻ അനുസരിച്ചിട്ടായിരിക്കും അതിന്റെ വാല്യൂസ് വരിക. ഓക്കെ, നമുക്ക് നോക്കാം, ഒരു എക്സാമ്പിൾ നോക്കുമ്പോൾ നമുക്ക് മനസ്സിലാവും. ഓക്കെ, സപ്പോസ് so these are the 5043210 code corresponding to the decimal digits. Suppose when you have to represent a number 0. Okay, suppose if you want to represent a number 0, how we will represent it by using 5043210 code. നമുക്കത് നോക്കാം. Okay, 0 ആണ് represent ചെയ്യുന്നത്. Actually 0 means it is less than 5. Okay, 0 means it is less than 5. So where we have to place 1, if the number is less than 5 means you need to, so this is the code, this is the weight, that is 5 0 4 3 2 1 0. ഇതാണല്ലോ നമ്മുടെ വെയിറ്റ്. ദിസ് ഈസ് ദ വെയിറ്റ്സ്, ഇതാണ് നമ്മുടെ വെയിറ്റ്. സോ ഇതിനെ നമ്മൾ റെപ്രസെന്റ് ചെയ്യും. നമുക്ക് 0 എന്ന് പറയുന്ന വാല്യൂയാണ് ഇവിടെ റെപ്രസെന്റ് ചെയ്യേണ്ടത് വിചാരിക്കാം. ഓക്കെ, നമ്മൾ ആസ് പെർ അവർ റൂൾ നമ്മൾ പറഞ്ഞിട്ടുണ്ട് വി വിൽ ഡിവൈഡ് ഇറ്റ് ഇൻടു 2 സെക്ഷൻസ് അല്ലെ. 2 സെക്ഷൻസ് ആയിട്ട് ഡിവൈഡ് ചെയ്യുന്നുണ്ട്. സോ ഫസ്റ്റ് സെക്ഷൻ ആണ് ഡിസൈഡ് ചെയ്യുന്നത് വെദർ ദ നമ്പർ ഈസ് ഗ്രേറ്റർ ദാൻ 5 ഓർ ലെസ് ദാൻ 5. ഹിയർ വി നീഡ് ടു റെപ്രസെന്റ് ദ വാല്യൂ 0. 0 ആണ് represent ചെയ്യുന്നത്. Then how we will represent it by using 5043210 code. That is what we are looking. Okay, so 0 is less than 5. So in that case നമ്മൾ എന്ത് ചെയ്യണം, ഈ 0യുടെ പൊസിഷനിൽ 1 ഇട്ട് കൊടുക്കുക. Okay, then here next 5ന്റെ പൊസിഷനിൽ 0 ഇട്ട് കൊടുക്കുക. Then corresponding 0 എവിടെയാണ് വരുന്നത്, ഇവിടെയാണ് വരുന്നത്. So you have to place 1 here. Okay, then all bits remaining will be make it as 0. Okay, so this is the equivalent biquinary code for 0. Okay, suppose if you want to represent 4, if you want to represent 4, then how we will represent the corresponding biquinary number for 4. So this is the weights for biquinary code, that is 5 0 4 3 2 1 0. So this is the weight. Then we need to represent a decimal number 4. Okay, decimal number 4. How we will represent the decimal number 4? In biquinary code, first we have to check whether it is less than or greater than 5. 4 is less than 5. Okay, 4 is less than 5. So we had to place a 1 in the place of 0, then put a 0 here. Then where the 4 come, evideya 4 varunathu ivida. Okay, so place 1 here, the remaining all zeros. Okay, 0 0 0 0. So this is the corresponding biquinary code for 4. Okay, suppose if you want to represent 7, then how we will write? So how we will write 7? So suppose I want to write 7. How we will write? 7 is actually greater than 5, isn't it? So place 1 here and 0 here. Then okay, so here it is already we go to 5. Okay, then we need to make it a 7 by adding just 2. Okay, so here the place of 2, the 5ന്റെ കൂടെ 2 add ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് 7 കിട്ടില്ലേ. അപ്പൊ 2 എവിടെയാണുള്ളത്, ഇവിടെയാണുള്ളത്. അപ്പൊ അവിടെ 1 ഇട്ട് കൊടുക്കുക. Remaining all bits 0. Okay, so this is the corresponding biquinary number for 7. Okay, so this is how we will write a biquinary code. Okay, so actually biquinary code means whose weights are what 5 0 4 3 2 1 0 5 0 4 3 2 1 0 and here we will group it into we will divide or it into two group. First is 5 0 and the remaining is 4 3 2 1 0. The first group 5 0 what it indicates that the given number is less than 5 or greater than or equal to 5. ഓക്കെ സോ ഈ ബിറ്റാണ് അത് നമ്പർ ലെസ് ദാൻ ആണോ അല്ലെ ഗ്രേറ്റർ ദാൻ ഓർ ഈക്വൽ ടു 5 ആണോ എന്ന് തീരുമാനിക്കുന്നത്. ദെൻ റിമൈനിങ് ബിറ്റ്സ് യൂസ് ചെയ്തിട്ട് നമ്മൾ എന്ത് ചെയ്യും, അതിന്റെ ആക്ച്വൽ നമ്പർ സ്പെസിഫൈ ചെയ്യും. ഓക്കെ, ആക്ച്വലി ഇത് നമ്മൾ മെയിൻ ആയിട്ട് യൂസ് ചെയ്യുന്നത് എറർ ഡിറ്റക്ഷൻ ഒക്കെ വേണ്ടിയിട്ട്. എറർ ഡിറ്റക്ഷൻ പ്രോപ്പർട്ടീസ് എ സർക്യൂട്ട് ദാറ്റ് റിസീവിംഗ് സൈഡ് can detect the presence of more or less than two ones and if it received a combination of both doesn't agree with the allowable combination. അതായത് നമ്മളിപ്പോൾ പറഞ്ഞു ബൈക്വിനറി കോഡിൽ 5 സീറോസും 2 വൺസും അതിൽ കൂടുതൽ വേറെ ഒന്നും വാല്യൂസ് ഇല്ല അല്ലെ. ഫോർ എവറി കോഡ് യു ക്യാൻ സി 5 zeros and 2 ones. Here also 5 zeros and 2 1. Here also 5 zeros. ഇതിലെല്ലാം 5 zeros and 2 1 അല്ലേ ഉള്ളൂ. Suppose if you are transmitting this binary code into a destination, അപ്പൊ അവിടെ എന്തെങ്കിലും ഒരു 3 1 വന്നു കഴിഞ്ഞാൽ നമുക്ക് മനസ്സിലാക്കാൻ എന്താണ്, there is an error occurred in this code അല്ലെ. ബിക്കോസ് എന്താണ്, in binary code there is only 2 1 and 5 0. Okay, so for error detection and all we will use this binary. Okay, so this is biquinary code. Okay, then one more. This is also example of biquinary code. Then one more code is there, that is XS3 code. Okay, it is also very simple. XS3 code. XS3 code of a decimal number is what? It is just by obtaining adding by 3 to that binary equivalent. Then you will get the corresponding XS code. Okay, just to add, suppose if you want to find the x3 code for a decimal number, what you have to do, just to take the corresponding binary equivalent and add a 3 to that binary equivalent, then you will get the corresponding x3 code. Okay, so that is what x3 code. Also, it is also a self-complementing code. We can see an example. Suppose if you want to find the x3 code for 5, okay, how we will find the x3 code for 5? First, what we have to do? Suppose this is the number 5. I want to find the x3 code for 5. First, we need to find the binary equivalent of that code. So, binary equivalent of 5. What is binary equivalent of 5? Tell me, anybody? Binary equivalent of 5. Anybody? Binary equivalent of 5. Binary equivalent of 5. Neha, tell me, what is binary equivalent of 5? Neha Fasal. കേൾക്കുന്നില്ലേ? ബൈനറി ഈക്വലന്റ് 5ന്റെ ബൈനറി വാല്യൂ എത്രയാണ്? മാളവിക?
Yes, sir.
Okay, പറ. Binary equivalent of 5.
0 1 0 1.
0 1 0 1. Correct. Then എങ്ങനെയാണ് നമ്മുടെ XS3 കോഡ് കാണുക? ജസ്റ്റ് ആഡ് എ 3 ടു ദിസ് അല്ലേ. 3 means 1 1. Okay. So if you add a 3 to this number, then 1 plus 1. മാളവിക കംപ്ലീറ്റ് ചെയ്തോളൂ. 1 plus 1. It is
0 with a carry 1.
0 with a carry 1. Then 1 plus 1.
0 with a carry 1.
0 with a carry 1. 1 plus 1.
0 with a carry
0
1.
with a carry 1. Then 1 0 0. That means 1. Okay. So this is the XS3 code corresponding to 5. Here you can see this one 5. It is 1 0 0 0. Okay. Suppose if you want to find the XS3 code for 7, how we will find XS3 code for 7? How we will find XS3 code for 7? Adul. How we will find Adul Sebastian? What is the binary equivalent of 7? Adul. Adul present alle?
1010.
Binary equivalent of 7.
1010.
Binary equivalent of 7.
അറിയില്ല സാർ.
അറിയില്ല. പഠിക്കണേ. ആഗ്ന പറഞ്ഞ ആഗ്ന പി.
Yes.
ഓക്കെ പറ.
0 1 1 1.
0 1 1 1. Then make it XS3. എന്താ ചെയ്യണ്ട?
0 plus here. 0 0 1.
0 0 1. Then 1 plus 1.
0 with 1.
1 plus 1.
0 with
0 with a carry 1. 1 plus 1 plus 1.
1 with a
1 with a carry 1. 1 plus 1.
0 with a carry 1.
0 with ഇവിടെ 1 ഉണ്ട്. 0 with a carry 1. Then 1. That is 1 0 1 0. So this is the equivalent XS3 code. Okay. So this is how we will find the XS3 code. Okay. So actually XS3 code doesn't have any weight. Adana weight ഒന്നുമില്ല, അത് ഓർമ്മിച്ചു വെക്കണം. Okay. So it is an unweighted code. XS3 code is an unweighted code. It doesn't have any weight. Weight ഒന്നും നമ്മൾ ഇവിടെ പറഞ്ഞിട്ടില്ല. It doesn't have any weight. So it is an unweighted code. We will get XS3 code of a decimal number by adding 3. That is 0011 to the binary equivalent of the decimal number. Then it is called XS3 code. And also it is a self-complementing code. നമ്മൾ പറഞ്ഞല്ലോ 9th കോംപ്ലിമെന്റ് കേട്ട് കഴിഞ്ഞ് കഴിഞ്ഞാൽ അല്ലെ, അങ്ങനെ കോംപ്ലിമെന്റ് ചെയ്ത് കഴിഞ്ഞാൽ അതിന്റെ 9th കോംപ്ലിമെന്റ് ആയിരിക്കും നമുക്ക് ഈക്വലന്റ് ആയിട്ട് കിട്ടുക. So that is self-complementing code. Okay. So this is what XS3 code. Okay. അപ്പൊ നമ്മൾ ഇന്ന് കുറച്ച് ഡെസിമൽ കോഡുകളാണ് പറഞ്ഞത്. സോ ഏതൊക്കെയാണ് പറഞ്ഞത്? 2421 കോഡ്, then 8421, sorry, 84 minus 2 minus 1, then 5043210, then XS3 code. ഓക്കെ. ഇതിൽ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ? ഉണ്ടെങ്കിൽ ചോദിക്കാം. ഇല്ലെങ്കിൽ നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം അല്ലെ. അഭിനന്ദ് അഭിനവ്
Present.
അഭിറാം
Present.
ആഗ്ന അഖില
Present, sir.
അച്ചൽ
Present, sir.
ആകർഷ്
Present, sir.
ഗോകുൽ
Present, sir.
അക്ഷര
Present, sir.
ആൽവിൻ
Present, sir.
അഞ്ജിത
Present, sir.
അനുജിത്
Present, sir.
അനുരാഗ്
Present, sir.
അരുണിമ ആഷ്വിൻ അശ്വന്ത്
Present, sir.
അശ്വിൻ
Present, sir.
അശ്വിൻ പവിത്രൻ അശ്വിൽ അശ്വന്ത് ടി കെ
Present, sir.
അശ്വതി
Present, sir.
അതുൽ
Present, sir.
ദീപിക
Present, sir.
ദേവിക
Present, sir.
Fatima.
Present, sir.
Fatimatul Misbah.
Present, sir.
Sahala.
Present.
Shibilia. Suhara.
Present, sir.
Gada.
Present, sir.
Gopika.
Present, sir.
Isha.
Present, sir.
Kiran.
Present, sir.
Malavika.
Present, sir.
Nabil. Mohsina.
Present, sir.
Mohsin. Muhammad Mohsin.
Present, sir.
Fahad.
Present, sir.
Sadef. Sahel. Nandana.
Present, sir.
Neha.
Present, sir.
Niharika. Nirmal.
Present, sir.
Nivedita.
Present, sir.
Nivedita. Nainika.
Present,
Punya.
sir.
Present, sir.
Punya present ആണോ?
Punya present, sir.
Rajat.
Present, sir.
Sahila.
Present, sir.
Sarang.
Present, sir.
Shana Shadin.
Present, sir.
Shanil.
Present, sir.
Shonin Selvaraj.
Present, sir.
Siddharth. Sunil.
Present, sir.
Saurav.
Present, sir.
Sriraj.
Present, sir.
Taifel.
Present, sir.
Varshanath.
Present, sir. Present, sir.
Vignesh.
Present, sir.
Vishnu.
Present, sir.
Pranav.
Present, sir.
Celia. ഞാൻ നിങ്ങളുടെ അസൈൻമെന്റിൽ ഇൻവോയ്സിൽ കൊടുത്തിട്ടുണ്ട്, അതെല്ലാവരും എഴുതുക കേട്ടോ. അതിലുണ്ട്, അതിൽ ഡൗട്ട് ഉണ്ടെങ്കിൽ നിങ്ങൾ എന്നോട് ചോദിച്ചോളൂ നേരം കേട്ടോ. അസൈൻമെന്റ് അതിൽ ഇൻവോയ്സിൽ ഞാൻ കൊടുത്തിട്ടുണ്ട്, നോക്കിയിട്ട് എല്ലാവരും സബ്മിറ്റ് ചെയ്യുക. ഓക്കെ, അങ്ങനെയാണെങ്കിൽ നമുക്കിന്ന് സ്റ്റോപ്പ് ചെയ്യാം. താങ്ക് യു.